Hi and welcome to Math Pre-Calculus 20, Section 4.3, Solving by Completing the Square, Example 4. Alright, so this example deals with somebody kicking a soccer ball away from her own goal, and the path of the ball is given by this quadratic function here, and it's h of x, so it's going to be the height versus in the x represents the distance from her own goal. So if we look at this here, we've got the net here. So that's the net. And she's not necessarily kicking it right from the goal line, so it might be along here. And then, so here's just our ground. And then this is like the path of the ball through the air. And so the height of it, is that h of x. And so basically, if we want to know the time when she kicks it, well, the height of the ball when she kicks it, is going to be 0, and we want to find the corresponding x value with that. Okay, so basically, we want to create a quadratic equation out of that, and the height we're interested in again, is 0, so it becomes 0 equals negative 0.06x squared plus 3.168x take away 35.34. And so we want to solve that equation for the x values. And those x values will give us this point here, and it will also give us this point here where the ball hits the ground again. Alright, so looking at this here, we're probably not going to be able to solve this by factoring, so let's look at using completing the square. First thing we could do, though, is get rid of this negative 0.06, so we can actually we can actually factor the negative 0.06 out of everything on that side. So we get x squared, take away 52.8 x plus 589. And then since it's equal to 0, we can divide this side here by negative 0.06 and this side here by negative 0.06. And this here, well, this reduces to 1, so we don't have to write it anymore. And this here, well, 0 divided by anything is just, it's just 0. So now we have 0 equals x squared, take away 52.8 x plus 589. And now what we want to do is we want to solve this by completing the square. So the first step that we do there is we take the 589 to the other side. So we'll subtract 589. So we get negative 589, but I'm just going to write that on the other side, or maybe I'll write it here for now. So negative 589 equals x squared, take away 52.8x. And then since I have negative 589 on that side, I can just write negative 589 on this side, because if it's equal, it doesn't matter which side of the equal sign it's on, so then I get it in the form that we like to work with it in. Okay, so now we're ready to complete the square. First step in completing the square there is to group these two terms. We group them, take anything out from in front of the x squared. There isn't anything in front of the x squared here. So then what we do is we go the b term, or the term in front of the x, so negative 52.8 divided by 2, which is negative 26.4. We square that, which works out to be 696.96. Okay, so now what we want to do is we want to add this to both sides. So we have x squared, take away 52.8x plus 696.96 equals negative 589. And since we added this on this side, we need to add it again, 696.96. Okay, and the point of doing that, is so that this here now can be factored and becomes a perfect trinomial square. We don't really see that, but the point of doing this is that it now can be factored to be x. And then remember, it's always this number here, take away 26.4 all squared equals, and then this other side of the equal sign simplifies to be 107.96. Okay, and then now we're ready to use square root property on this. So we can take square root to get rid of that bracket squared there. Square root here, put a plus or minus on that, remember, because it could be a positive answer or a negative answer. So we end up with two solutions here. We have x equals the positive square root of 107.96 and then add the 26.4 over. That's one solution. Or x equals the negative square root of 107.96, add the 26.4 over. So those are our two solutions. And now here we're just going to approximate this with a decimal. So we'll have x equals, so we just put the 107.96 in our calculator and square root it. So we get 36.8 meters, because it's measured in meters here. And this one here is 16.0 meters. Okay, so our two x-intercepts, we could think of them here, where the height of the ball intercepts the ground is at 16 and 36.8. Right, so if we look up at this picture, well, this one obviously is the 16, this one's the 36.8. So part A asks how far away is a soccer ball when the ball is kicked? Well, it's the 16 meters. So that's the answer to part A. And then part B asks how far does the soccer ball travel before it hits the ground? Well, again, if we look at this graph of this ball, well, it goes from 16 to 36.8. So we just want to know that distance. So to find that, right, it's just going to be 36.8 meters, take away 16 meters, and that works out to be 20.8 meters. That's how long the ball's in the air for, or the distance it's in the air for. Okay, so we've solved that by completing the square, because other methods such as factoring wouldn't work very well here. It wouldn't work at all using our normal factoring methods. And graphing it is an option. We would be able to graph it and get this answer, but we don't always have kind of the technology to graph it well. And then there is another way, which is the quadratic formula, which we'll look at tomorrow. All right. Thanks for watching. Good luck.